Okay, on to continuity. So we have two different parts here of the continuity section. We have proving continuity using equations and proving continuity using a graph. So it works the same. When we're proving continuity, we have to have three pieces. We have to have the limit from the left, has to equal the limit from the right, and that has to equal the function at that point. So if you're imagining what that graph would look like, you're thinking this: the limit from the left, the limit from the right, what's happening at that point? They all have to be equal. From the left, from the right, the actual point. That's it. And really here, these two, the limit from the left and from the right, that's the two-sided limit. That's the big limit. So if you find that that limit doesn't exist, you're really done. It doesn't matter what the function is at that point. Sometimes it can be a little more tricky to look at it with equations instead of a graph. But you can, all we're doing is the math here. Okay? So from the left is from smaller numbers, from the right is from bigger numbers. And I'm going to do work in that order. So where x is less than 2, here is what we're going to use for the limit from the left. And since it's equal to, that is also going to give us f of 2. And what we're going to use as the limit from the right is where x is greater than 2. Limit from right. Just to plan out our problem for you. So, here we go. The limit as x approaches 2 from the left of f of x is this. So I'm going to plug 2 into x squared. So that's the limit as x approaches 2 from the left. And since there's that equal to there, I'm going to go ahead and write out f of 2 is also 4. All right, now the limit from the right, from the bigger numbers, from numbers greater than 2. And for this, I'm going to use 2x minus 1, because that's this function, that's how this function is defined, where x is greater than 2. So 2 times 2 minus 1, so that's 4 minus 1 is 3. So since our limit from the left does not equal the limit from the right, our function is not continuous. Limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x. So our function is not continuous. At x. All right, let's work part B. Different functions. So here we're looking at x equals 1, and our two functions are 3x and x plus 1. So where x is less than or equal to 1, that's going to be our limit as x approaches 1 from the left. And that's going to give us f of 1 as well. And this guy down here is going to give us our limit as x approaches 1 from the right, since it's where x is greater than 1. All right, let's just go ahead and fill in our numbers here to this little sketch that I've made for us, this little plan. So from the left, we're using 3x. 3 times 1 is 3. So that's the limit from the left. And since we have an equal to there, that's also our f of 1. 3 times 1 is 3. So from the left and our point at 1, those values are equal. Now we need to plug into x plus 1 to get our limit from the right. Well, from the right, our function is 1 at our x plus 1. And our function here is not continuous. The two-sided limit does not exist. It's a jump discontinuity, since you would have to pick up your pencil in between there to graph those lines. All right, one more example. So we're evaluating our limit for h at x equals 4. And this one's a little bit different. Our left-hand limit, we're going to use x plus 9, where x is less than 4. So from the left, from our number smaller than 4, we're going to use x plus 9. And from the right, and for our h of 4, we're going to use x squared minus 3. Since that is the piece of the function that's defined where x is greater than and equal to 4. So we're going to use this equation for as x approaches 4 from the right of h of x. And we're going to use this equation for h of 4. All right, let's plug in our values. So I'm going to plug in 4 for x plus 9. 4 plus 9 is 13. So our limit from the left is 13. I'm going to plug in 4 for our right-hand limit. So x squared minus 3. So it's going to be 4 squared minus 3. But 16 minus 3 is 13. So for the first time here, our left-hand limit matches our right-hand limit. And now let's find h of 4. Well, that's the same. Still 4 squared minus 3, which is 13. So our left-hand limit matches our right-hand limit, and that matches h of 4. And since that is the case, our function is continuous at x equals 4. Limit as x approaches 4 from the left is equal to the limit as x approaches 4 from the right. Those h of x's are important. It doesn't make any sense if you just say limit there. Equals h of 4. So our function is continuous.